Live. Hold on, let me just quickly change this setting. That should be okay. Oh, it's complaining that I have got my microphone set too loud. So hopefully this is better. Yeah, if anybody can let me know whether the sound is okay, that would be great. But should be all ready to go. I haven't got my green screen on at the moment, but yeah, should be okay. Hopefully it doesn't, the camera doesn't hide too many things. Hey Dave, how you going? So, okay. Sweet. Thanks for letting me know. Anyway, tonight, I want to go and have a look at this. So this was an article that I found a little while ago. It isn't, well, it's not a too old article, about a year old. But then based on Unity on creating a rigid body based controller character where the hands are actually working, properly interacting with the environment and moving the player body around. So we shall see how far we get with that. Hello, Devisant and Genus. Sorry if I mispronounce your name there. I am terrible with names. Anyway, I'm just putting the article on my other screen. And then let's see how far we can go in reproducing this in Godot. So, I've got a brand new scene here. I've got my main scene now pointing to that new scene, so it should start that one up instead of the normal one. And that is completely empty. That also reminds me, let me move a few things around to make sure I can grab my controllers. Also, I might just want to make sure that Steam is running. Oh, I probably don't even have Steam running here. Hang on a second. I'm well prepared for the stream, obviously. Not having started everything. Come on. Why do you start almost full screen? There we go. Let's go away with that. And that should now allow me. There we go, to connect to SteamVR. And my cables are getting all tangled. Yay. Okay. This is now running SteamVR. Perfect. All right. Okay. So. Excuse me. My eye is giving me problems for some reason. All right, so the whole idea here, well, obviously I've got my very basic scene at this point in time. It just has a world environment for lighting with the light here. That might actually not be set up correctly. Not that it really matters. The sun is over there, so I want to make sure that that one points in the right direction. That is good enough for me. Yeah, it could be usable for that. Because indeed you could fix the rigid body in place. Although you still, of course, need to make sure that your player can move the head around. But you probably could do more control-wise. But we'll see how far we get with it today, because there's a couple of things that will become more difficult with this scenario. So we'll have to see. Okay, so let's start with adding our rigid body in. We're just going to put our components in place, and then we'll figure out what the logic is that we need. So there's our rigid body, and obviously we want to have a collision shape for our rigid body. And we're just going to go and put a capsule shape here. Capsule shaped. There we go. Now, obviously, that's not going to be correct. I do want to make that a little bit smaller. I also don't want it to be it be that big. I'm actually, and I might not get to it in this stream, but I actually want to make a more complete collision setup for my player at some point. But for now, this will do. I guess like this, yeah. So now it's nicely on the ground. And we should be able to move that guy around. Now, at this point in time, there's a good chance that he will actually fall over. So, let's go back to here. Let's give this guy a bit of a proper mass. We're going to make our guy 75 kilograms. We'll leave that normal. We'll leave that normal. We'll leave that normal for now. Maybe at some point we want to continue in CD, but I don't care about that. And we got linear and we got angular. So probably at some point we're going to have to do something to make sure that our player keeps upright, that he doesn't fall down just because we move. But we'll get to there that way. We get to it. All right. So that is it. Basically our character that we should be able to move around with and have something, have it do something. I'm not going to use any further bits of extra tools at this point in time, but you know, if this all works, eventually I do want to port it to extra tools. For now, we're going to create everything anew. So we need an extra origin point. We're going to make that a child of the rigid body. Now this project should, I think this is actually set up. Let's see. Well, it's set up with local floor. So when we reset our view, we will already be centered. But if we're not centered, then that might give us some problems. But we'll force it to be centered when we started just by pressing the recenter button. Because right now there's no logic that makes sure that we adjust the extra origin to be centered on the rigid body. Might do that. Yeah, might do something for that. We'll see that in a minute. Also, I'm going to make the logic where if the player physically moves, and therefore, you know, my headset tracking moves away from the rigid body, that logic is probably going to be last. For now, I want to concentrate on the hand logic and controlling the rigid body by controller input. So for direct movement, to make sure that all works. So there's going to be a few things that will come at the end. We obviously need an extra camera here, and as always, I do like to place that somewhat. It's a bit too high, I think. Somewhat in a place where it is to be expected, but we'll stick to that for now. Okay. All right. Oh, it always does that. So the last thing that we need to do as part of our logic here is nominate our extra origin, so that when this scene gets current, that setup gets enabled. What I also want to do is I want to add a mesh instance here, and that's just going to be a sphere, and I want that to be a little bit smaller, not too small. So there's just a sphere that's on the ground of our player. And that means that when we look down, and obviously I'm using the spectator cam, so you guys can't see when I'm looking down, but I can at least see whether I'm standing above the controller and making sure that that's all working. So let's first see if this runs and then start looking at adding some basic movement there. Okay, let's go and do that. Actually, we need to do the hands first. Where's my mouse? Here we go. All right, so I hope that yeah, that's I'm actually on Dev 7 here, so unlike last time where, oops, I was using the latest master, I just decided to go slightly back. Now, I'm in a seated position, so I'm actually somewhat on the low side, but I can look around and be happy. So that's really cool. And I'm properly centered, which is kind of cool. So we got lucky there. So let's go and save this. And I'm actually going to put that in here. And I'm just going to call that player rig, just so that we have that in a subscene, makes it a little bit easier to work on. I'm just going to put a script here on the bottom for the logic that we want. All right, I might actually want to go and do a little bit of basic logic. Now, normally I try and put a lot of logic on the XOR origin, and I might eventually move it there, but because I want this to work as a complete setup, I'm just for now going to put the logic on the rigid body itself, which I think should work just fine. Let's think this through. I actually do want to have a recenter logic. Where is that going? Buzz? I don't know. Let's call that on pose recenter. And let's also get a ready function. Okay. So I'm going to steal a little bit from here. So this is a normal dynamic. I actually want to have that in here. There we go. And I'm actually going to steal a little bit here from the start. It's, even though this is not yet a tool script, it's very likely that this is going to become a tool script. So we're going to exit if we're in there. I'm not going to care much about that, but I do want this bit. And actually, let's copy that whole bit over. And we're going to go and paste that over here. I'm going to take that comment out for now. And let's rename this the same as the other one. So what I'm doing here is I'm getting to our start script, which is actually living over here on the main scene. That tracks our XR interface. So and there's a little bit of handiness there. So for instance, on post recenter, we actually get this post recenter signal. So all we're doing here is, if we have that, we're actually going to go and recenter or react on a recenter command. So that's when the user holds the little button to recenter in the headset or whatever equivalent there is on the runtime that you're using. And we get that signal and we can react to that ourselves. Now, the post recenter itself here. Hey, not another dev. Good morning. So we're going to steal a little bit more out of here. I'm actually going to go and copy a little bit from here, even though we don't want all of this. I just want to go and borrow a little bit of this, because a lot of this, I want it to work the same. So I actually also want an onReady var here for my origin. So that's going to be the XR origin, and onReady var for our camera. This is just to make it easy, and also if we move it somewhere else at some point, it's easier to edit. And seeing that we have a number of scenes that have origin and cameras, I'm a little concerned to make those unique. So you can do the, where is the option? Access as unique name, but yeah. Ah, Dave, you're in New Zealand, so you're not too far away from me then. Just a stone throw away over the pond. All right, so what are we doing here? Copied from the other stuff. So we're doing a getting our play area mode from our start XR. That's the basically getting the setting that we've set over here. So whether we're local stage or local floor, and making sure that we react accordingly. So we've got a little warning here that if we're in sitting mode, this rig is not set up for sitting mode, but maybe we could do something with that at some point. Sydney, yes. Well, imported Aussie. I'm originally Dutch, but living in Sydney at the moment. So room scale, that's stage. So in this case, oh, that's actually the local for option nowadays. So in this case, it says, well, you know, we've already handled it by the headset. That means that the headset is going to make sure that we're centered. So our XR origin point is going to be directly under our camera. And we're going to be looking straight ahead as far as the null transform or an identity transform XR origin is concerned. And the final version is where we're doing it ourselves. So this is basically doing the exact same things that the headset does internally. Make sure that the XR camera is on top of the origin point. Now, normally the way that this works is that as we move around physically and our camera moves away, we're going to try and keep the camera above the rigid body. So we're going to keep moving the rigid body to be underneath the camera whenever, you know, the player physically moves. And in order to do that, our origin is going to be moved in the opposite direction. That's all the logic that we already have in our dynamic rig. Logic that for this rig will do last. Important. So we're going to leave that out for a bit. But the challenge here is to always have the camera stay above the rigid body, and the rigid body therefore follows the player around. Now, when we reset, all of a sudden our camera is put above the origin point, wherever our origin point now is, because that's going to be any space, really, depending on how much we virtually moved. So the next thing that we're going to be doing here, it's actually going to reverse some logic. Now, this actually does a little bit more because it gets the head tracker, and we're going to go to the neck. I actually want to remove a lot of that. We're going to just assume that the camera is going to stay above the origin point and therefore also stay above the rigid point. We're not going to make it that funky. So I actually want to take all that out, which really means that we can just put our origin node. We can actually just create a new transform for that. Okay, boink. So this now means that our origin will be on top of our rigid body. Our camera is already on top of our origin. We're nicely centered on our rigid body. And our rigid body should already be facing the direction that our player should be facing. Now you can see that in the original, I also reorient our rigid body. Oh, this one, by the way, needs to be our origin node. That's the origin node needs to be transformed. So here we're just going to say reset our XR origin transform. Boom. Then we're happy. And then we have a little calibrate height function that we can do here. And I'm going to go, actually, let's go and be consistent in our naming. Make sure that that is XR origin. There we go. We got our XR camera there. And we can do a target height. Now, I've already made that so that if we have a target height set to 0, we ignore that logic. So this is obviously going to be an export variable. And I actually want to make that a range. We're going to go and say that our character should be between 1 meters and 2.5 meters. That's fine. And then meters. There we go. var. I'm actually going to copy the same target player height. And we're going to specify a target player height of 1.8 meters. Okay, we're going to create a setter for that. There we go. We have a target player height of value. And here we're going to say if is inside tree. Then we're also going to call our calibrate height. So if we change our target height, which is not really something that we would usually do, we would recalibrate our height. Obviously, we need a function for that, so make sure that this thing is happy about it. And we're going to implement that in a minute. So the very first time our script runs, we do a post recenter. We're going to calculate our height by default. Whenever our target player height is changed, we're going to recalibrate our height. And whenever the user recenters, we're also going to do our calibrated height. Now, why do I do this calibrated height logic? And again, it is optional logic. Not everybody wants it. It also depends a bit on the situation that you're in. But I'm sitting down on a chair, and I still want to be able to play my game, whether I'm standing up or whether I'm sitting down. The game is designed for the player to be of normal height. In this case, 1.8 meters. So I want to make sure that my player is actually adjusted to that height. And I'm going to do that by adjusting the Y coordinate of my origin, either up or down, to make sure that we adjust for that height. However, before we do that, we want to make sure that our that we know how much to adjust it by. And we're going to do that by measuring where we currently are and then adding the difference, or remembering the difference. Now, the other thing that's really important here, when you create a XR game from scratch and you load up your scene right away, which is not what we're doing, it can take a couple of frames before you actually get tracking data. So if you do this logic like I'm doing right now in your ready, there's a chance that you're calibrating your height before you actually get tracking data, and therefore you're not going to calibrate the right height. In this case, because we're using our staging system where the player loads into this loading environment, and then we load in the screen and we wait until the player presses a button before the actual scene starts, we know that we have all our calibration information. However, the downside of the way that our nodes here work is that our nodes might also not be updated yet. They're usually updated on the first frame. So we are going to go, in our calibrate height, we're going to go to the source of the data. And again, I am going to steal some of that logic from here. I'll actually copy the whole block because I know that this works. So let's put it in here and let's just go through this code and see what we are doing here. Obviously, I do need to have my variable here and my I adjustment. So let's go and copy those over. I think one is a constant. It is. So let's copy that one over and put that at the top here. So I've just got a constant here, which is, I know what my eye height is over here. So my total height of my player, from my height measured from where my camera is, I need to add 8 centimeters, which is roughly that spot. Not exact, but, good enough for government work. Oops. Sorry about that. All right. So that is that. Now, the other thing, obviously, is we need a variable to store our height adjust in. And while we're at it, some handy variables to know. Let's put a little bit of comments in here. And here we're going to do a double comment because we want to make sure that that is... and actually, let's just copy that from here because I've got a really nice little thing over here. So we do double pounds so that it actually becomes part of our help system. Very cool. So auto calibrate the user's height on recenter. Set to 0 to disable. Yay! And that should now also be visible here. Very cool. All right. Sweet. All right. Player, transform, calibrate our heights. Yeah. Go on, any comments here yet? No, I don't really care. Double new lines is supposedly what's the right word for that? Oh, my English is failing me. This is standard in layout here. All right, so what are we doing here? The first thing that we're doing is, like I said before, we can't trust the XR camera 3D node just yet. So we're going directly to the XR server to get our head tracker. That is actually the internal data that is always up to date. That's always directly managed by the XR interface. So grabbing that gives you the most up-to-date data, which is cool. From that, we get our default pose. That's the only pose that exists in the head tracker because this is not going through our action map. This is just standard stuff. And we get our transform for that. So that is the XR camera's local transform in the XR origin space. That now gives us where our head is. And the only thing that we're interested in is the Y value of that. How high is our camera up? What is our eye level? I could be looking down, I could be looking up if I'm dumb enough to recenter at that point in time, and I might be slightly off, but it's close enough for what we want to achieve. So now we're going to say, what is our target player height? We're going to take our eye top off so that we're at eye height. We're then going to take our camera height off. So now we know how far down from the top of our head our XR Origin 3D needs to be. And we therefore know the amount that we need to adjust. And we're simply going to assign that. And this is originally from a script that is normally attached to the Origin node. So we need to adjust the Y position of the XR Origin. It's probably going to be a little bit more that we need to do about that, but we have our height adjust here. So if we are moving things around for tracking reasons, we can deal with that. Now, obviously, after this calibration is done, I can stand up, I can go down, and obviously I will change my height accordingly. So let's see if our calibration works. And I need to be careful that my wires don't get stuck. Although maybe I will take off that. Oh, my... Okay, I need to fix that in a second. Oh, that's interesting. Hold on. Why is that suddenly... Oh, that is because I moved that into that, and now my player origin... So it was actually not working properly. So I need to go to edible children, which is a bit annoying that I need to do that in order to get there. And now if I run it, I should actually, because you guys saw the right thing, but I saw the wrong thing. All right. So, okay, we're calibrated. Now the question is, am I on the right height? It kind of feels right. Yeah. We need something for reference so that we can know that we're actually at the right height. So let's go and create a couple of helper meshes. Actually, let's go and have some fun with that and actually create a rigid body. Let me call that box. Let's call that box 01. We're going to make this a box of 1 meter by 1 meter. That's good. That means that this can be a little up and a little forward and a little to the left. Let's give that box a bit of weight so we can have some fun with that later on. Let's then also make sure that we have a collision shape of that. There we go. Actually, let's go and just do it like this. I want to actually put it in that because we have other boxes in the other one. Actually, I could have just done that, of course. Maybe I'll just do that. See, because I've got a box in my MISC script. I should just reuse that. Box, and then delete. I don't need you anymore. Let's instead just add the boxes that we already have. There we go. There's a nice box, but I'm going to make that a big box. There we go. There we go. I can move that to the side, and then I'm going to make that a bit heavier. So this box should just be a normal thing with a label. Cool. Okay, now I want another box. Box 2. And I actually want that to be 2 meters. An even bigger box. And again, for now, it's just really to just have something to scale. But also later on, we'll have some fun with what those things can do. Oh, that didn't update right away. That's interesting. All right. Let's see if that gives us an inkling whether we're indeed the right height. Obviously, we can't really move yet. Yeah, I can look over the 1 meter box, and the 2 meter box seems to be slightly above eye level, so I think our calibration is working. Cool. And I am still above my little circle. Cool. Hey, the wheels, how you going? Okay. let's continue setting up our player rig. Now, here's an interesting choice. Do I make my hands, because they're going to be rigid bodies that because we're actually not going to be using, what do you call it? We're actually not going to use XR nodes for the hands. So I might actually make that separate objects, and that actually sort of also creates a bit of a picture about how I want to make this all work together. So we're going to assume that that is something we can do. And actually here we go and have a look at our article here. All right. So what he says is, for these hands, we're going to create them directly attached to the body, so that way you can prevent them from going too far or not. Start with a rigid body player controller. Well, we've already created that. And a pair of rigid bodies for the hands. Now, I think, but I could be wrong, that these are separate objects that are next to each other. And the question is whether we need to do that for ours as well, which basically means, let's work on that assumption. So we're going to add a rigid body here for, and I'm not going to, I'm not yet going to create that as completely separate objects. Well, yeah, maybe for now we're going to do that. So we're going to actually create a hand body, and I'm actually going to go and save that in our tester script, and it's going to be hand body, because eventually these are going to be replaced by the hand logic that I already have. But what I want to do here, and we might actually just do that in script over here. So we're going to go and create script here. And for now, for this little guy, let's start actually with that. Mesh instance and a collision shape. Create a box. Actually, I want them the other way around. And here I want a box shape. And obviously they don't need to be that big. I should have done this one first. 1, 0.05, 0.1. Okay, so we're just going to have these little flat things to be our hands for now. That's good enough for what we need it to be right now. And here we're just going to use our normal thing. So we've already got our palm pose. So we're just going to be using our palm pose on this. All right. So in our script here, let's start with a ready function. And we want to make sure that top level is true. Because we want to track these in normal space. Now the other thing is, well, we'll see how well that works. Because again, there's another part to this that we need to use. But for now, let's give this an export enum left, right for hand is 0. That should be int. So that guy is left. Left or right hand. Boom. And we want our export variable pose. And that's just going to be palm pose for now. Action pose to use for tracking. Because I'm not going to be using our hand tracking just yet. I'm just going to purely base this on that. Which actually also means that for now, just for this experiment, I'm going to go and turn off all my hand tracking stuff. Yeah, sure, go for it. Oh, that's not going to complain that that it doesn't like this, probably. Yeah, it's still happy with that. All good. Okay. Good enough, I think. So we have our hand that we're using, and we're having our pose that we're using. We're having our hand body that tracks. And yeah, we have our collision shape. Okay. So. We might eventually get a problem once we start moving our X or origin point around, that we need to make sure that we reposition other things as well to keep them properly in global space. We'll worry about that later. Because, yeah, we're going to have an issue with the order in which we do things. And we might actually end up putting something in the wrong place. Although that is something that we can organize by making sure that things are happening in the correct process order. For now, we're not going to worry about it. Now, what I mean by that is, once we have our movement logic and specifically our physical movement object logic, we're going to, take a step forward in physical space. That means that now our character body or our rigid body is going to move forward, but our X or origin is going to move back. But I think it doesn't actually really matter, because for that sort of movement, our hands will still stay in the right place. But it is our body movement where we're hopefully going to have our body movement also move our hands. Yeah, we're going to have to see how well that all works together. Because that's the thing that is not clear here is, because we're going to use a joint to connect the hand to the body. But a big question is whether we need to have that joint fastened to our rigid body. Because the location of our joint is going to be important. Yeah, so let's create that joint in code. And we're actually going to go and create that on the parent. So we're going to make sure that our parent is our rigid body, because we're going to create that joint between our rigid body and our hand body. But it's that joint that is going to be positioned. Okay. So let's create a variable for that, and that is going to be our six-dot joints. Generic system, so thank you. So we're actually going to be creating that. We also need to go get our parent body. There we go. Let's make a function for that. Okay, so parents. Parents. There we go. All parents. Parent is parent. Get parent. So we're going to go down our path, and here we're going to say if parent is rigid body 3D, then we found our parent. We're going to return that, and else we're going to return null because we haven't found it. That means that here we can now say parent body is get parent body. There we go. But it also means that we can create a get configurations warnings. Let's call it warnings. It should be a patch string array if I'm not mistaken. We can actually say that that is what it returns. And what we can do here is for parent is get parent body, if not parents, warnings, push back. This needs to have a rigid body as a parent. And in this case, I would even say that it actually we should always do that on the parents. Instead of going all the way down. Now, let's for now assume that we can have some levels in between if we really want to, because this thing is going to be top level anyway, so it won't really matter. All right. Okay, so in theory, actually, let's go and reopen that. Oh, because now this needs to be a tool script. Which also means that I want to make sure that we don't run this in the editor. Oh, this needs to suddenly be reopened. Yeah, now we got a warning here because it never has a parent here, so it's going to give a warning over there. But here, if we reopen that one, it's happy because that's has the right parent. Cool. All right. So far, so good. So, that actually reminds me that we should do and add another one here. I'm going to just say this becomes our left hand, and this becomes our right hand. And I'm going to make that right. So, perfect. All right. Then, if we have a parent body here, we obviously need to set up our joints. So, okay. All right. New, so create a new 6DOF joint. Hey Wes, how you going, buddy? Hoe is het in Nederland? Okay. We're actually going to go and add that to our parent body. I don't care about that, but we are going to make that an internal node because we don't want to actually see that in our node tree. It's going to be an internal thing. All right. So there's a couple of things for the 6DOF joint that we want to set up right away. And there's a couple of things that we're not going to do right away. All right. I need some more drink. Actually, let's first make sure that we have a bit of a default location for these guys, even though it's not going to be the right location, but we don't want it to be in a bad location. So let's go and let's put a 1 meter, minus 0.5, minus 0.5, and then this one as well. Where are you? Where can't I see it? Oh, here. 0.5 minus 0.5, just so that it has a good starting location. Oh, it's Excel. Nice. Yeah, pretty uneventful Christmas so far. Just went out to lunch with some friends, and other than that, just chilling. Okay. So, so the first thing is that we need to specify which nodes we have in here. So these are node paths. We're going to start with our parent body. I think it's just get path. Yeah, there we go. And 6 joints.node B is going to be our hands. So that joins our body to our hand, and yay, we have those two together. All right. Then we add it to that. I obviously also then want to give our 6 joint a default location. So here we're just going to say global transform is our global transform of our hand. So just so that we have an initial position for that to be. Now, let's add a 6 over here, just so that we can see what sort of things we got to play with. Because by default, we have a 0 X limit, so that means that it's always going to be placed on our 6 joint. We don't have a linear motor, I think. No. We don't have a linear spring. This is probably something that we're going to need to enable. But we also, I don't think we have an angular limit. So in theory, our hands should always end up being placed on our 6 joint, as long as we make sure that our 6 joint is being positioned where our hand should be, in theory. Let's delete this 6 joint. I don't think it would hurt. But the other thing that I want to do, and this is just for testing, no, actually, this is the new, and then we want to mesh, clear mesh. Okay, then we need to configure our mesh. Okay, then I'm going to assign it to our mesh instance. And then we're going to say 6 joint.add child mesh instance. Let's make sure that one's also marked as internal. So let's keep it consistent. So all I'm doing here is I'm just creating a small little circle, a little sphere, and I'm adding that to our 6 joint so that we can see where our 6 joint is positioned. Excuse me. Now it should be inside of our hand, so we probably won't see it. Although, how big did we make our hand again? No, the mesh should be bigger than the hand, so it should actually fit nicely inside. Okay, so now we just need to do our tracking, and obviously we're going to do that in our physics process. Okay. Cool. All right. So now in this case, we know that our tracking is inside of our rigid body. We can use global positioning for that as well, just to rule out any crazy restructuring that someone might do. So let's go and steal a little bit from our rig here. No, we're not going to steal anything. We're going to write it from scratch. So the first thing that we need to do is we need to get our tracker. So in this case, we're just going to do a XR positional tracker because we're only interested in the positional bit. Everything is subclass from that. I'm going to go to our XR server. We're going to get our tracker. And in this case, we're going to go for left hand, I believe. If hand is 0, else it's going to be our right hand. I believe it's what they're called, but let's double check that. by just getting our, oh, my headset just timed out. Yippee-yay. Okay. Yeah, so left hand and right hand, those are two special versions. So, okay, so if we have a tracker, we're happy. Then we need a pose. And we're going to get that from our tracker by saying get pose. And the pose that we want is actually the pose that we defined here. So we can get that just nicely. And here we can say if we have a pose and pose has tracking data. I think that is a property. Yep. So you should just be able to get that. All right. Then we just need to get our adjusted position. So our adjusted transform is actually our tracking transform, but adjusted for both our internal recenter logic, if we're using that. In this case, we're not because we're using local floor. But also if we're using world scale, that correctly applies that. All right. So now we need to make sure, because that's a local transform, we need that in global space. So what we're going to do for that is we're going to grab our world origin from our XR server, and we're going to multiply those two together. So now we have our T in global space, and that should mean that we should be able to say 6.of joint global transform is T. Now again, this could give us problems when we start moving our XR origin point around. So I need to make sure that we do things in the right order. And potentially, instead of using this, we might actually want to grab the XR origin from our RigidBody so that we are in the correct space, pre-XR origin being adjusted or the other way around. But we will see. We have some options there. Might actually put a remark there. Might want to use actual position of XR origin 3D on RigidBody instead of grabbing from server. Server may not be updated. It should be, but we'll figure that out. So this should mean that our 6.of object is now moved to where a hand should be. And because our 6.of by default wants the hand to be where the 6.of is, it should pull our hand to that location. So if we've done everything right, we should now see moving hands. But I do first need to make sure that I'm back in our good friend SteamVR, because my headset went to sleep and killed off SteamVR. Yay! Yep, and it always takes a little while before it figures out that it's no longer there. So there we go. And now I need to reconnect, and then you got a good chance that it says, but hey, that's not the right session. Hopefully, oh, it is been long ago enough for it to not care. Alrighty. All right, well, so our hands have fallen on the ground, and I can actually see some stuttering, so it's trying to do something more with our hands. But also, our 6.of should be on the right spot. So, yeah, something's not working the way that we want. I'm actually going to keep this open, though that flickering has to do with it trying to reposition things in a way that's not properly working. Let's go and have a look behind the scenes whether everything is created. Now, the problem, of course, is I made everything hidden. Maybe that wasn't a smart idea. Okay. The other thing, of course, is how heavy are our hands? Our hands are probably just a kilo. That's fine for now. Okay. It's possible that it might have given us problems with that. Oh, because we have called this pose. Tracker effects. Actually, no, let's go and rename this guy pose action, because that makes actually much more sense for that. So that's still good. That's still good. Okay, so let's figure that out now. Whether that has anything to do with it not working, I don't know. Could be. Let's have a look. No, they're still falling to the ground, and we're still not seeing anything there. While I was doing that, I should really have just removed this. So I'm actually going to just make that a comment, because I do want to reintroduce that later on. But for now, I don't want to do that, so that we can actually see if everything was created properly. Dunk. All right, cool. So now we should be able to go and have a look. Let's move that out of the way. Go to remote. You should now have seen that properly, dude. So this is weird. It's like it hasn't refreshed it, because we should have at least seen these guys. So what's going on with this? All right. Blank. Yeah, still not working the way that it should. Remote. Oh, because I'm looking at the wrong one. Haha. I need to look in here. Here we go. Here's our rigid body. Okay, we got our left hand. Got our right hand. We don't have our 6 doves. So our 6 doves weren't added properly. Or it was never able to find our parent body. That's also possible. All right, so maybe we should put some which error, couldn't find parent body. Okay, so that's at least that. Up. No, parent body at child. So and here, parents body. Actually, for that, let's just put a breakpoint there and see if it actually does something. Okay. Boom. All right. Well, it got in there. That's a good sign. We have a new joint object. Okay. So that's the object that we just created. This is still set as an orphan. That doesn't make much sense. I think this probably we should add in after we add the child in. I think that's probably a good idea. Let's go and add that in first. Maybe also position it first and then add these in. Okay, let's see if that makes a difference or not. So I've removed my breakpoint this time because I just want to go and do that. I want to move that down, and I just want to look at our remote, scene, test rig, rigid body, and I am now expecting to see our 6 off joints here, which I'm still not seeing. We did not remove that, but it was added to our parent body. Unless our parent body is the wrong one. Okay, what is our parent body? Yeah, parent body is... subview for main rigid body. So that is so far good. Step over, step over. Okay, so now I want to have a look at our 6dov. That's still an orphan. So it's not allowed me to create this as a child to my rigid body. Parent node is busy setting up children. Add child failed. Consider using add child called deferred. I am not allowed to do that in my ready function. Huh. Okay, so yeah. That kind of sucks. Well, one thing that we can do is that we actually move it to here. Okay. I actually want to do this like this. Blink. Oh, blink. There we go. And we're actually going to go and move this out of here. And we're going to move that here. If not 6 of joints. Sorry, I just need to park that there again because I suddenly realized I also want to make sure and I don't run my physics process when I'm in the editor. There we go. So now we can move this over here. So we're going to say if we don't have a 6dov, oh, actually, if we don't, oops, parent body, and we're going to go and return. So if we couldn't find a parent body before, then now that also means that I can just change that to this. Boom. So now we just have the situation that we get in here. We make the stop level true. That's all good. We get our parent body, and if we can't find a parent body, then cool. I actually also want to make our freeze true here. And we're going to make that false over here. Actually, I want to do that before I do my testing, because we're eventually going to remove that. So now that we have our joints, unfreeze our hand, blank, because now we want it to start tracking. Cool. If we somehow failed to create our 6dov point, then we obviously want to return there. And in this case, we just get our tracker data and we set our 6dov joint in the right position. So now it should be creating that after our ready is finished, as early as it needs it. And hopefully that will do the trick. Well, let us see if that makes sense now. Okay. All right. Whoa, that is trippy. Yeah. All right. So, well, our joints are put in the right place, but our hand still fell to the ground. So, I guess that's why we fell over, because our hands have probably pulled us to the ground. Okay. So. That is interesting. Now, one way that we can actually have a quick, tricky to make sure that that is indeed what's happening is I'm going to turn the gravity off on our hands so that our hands don't fall down. So let's go and have a look at what that does. Okay, now we haven't really fallen down, but our hands, they aren't being attracted to our position. So we're going to have to work on that first. Now, that was just a trick to see if, something was doing what it should not be doing. But we do want gravity to work on our hands, so we're going to leave that the way that it was. Now, where's my physics article? Here it is. And this is the other thing which is annoying, is that obviously the rigid body and our joint logic in Unity works differently than in Godot. So we're going to need to figure that out. Oh, look at that. He's also having the same problem that, yeah, no, it's all falling around. We had the extra difference that the hands falling to the ground pulled over our rigid body. And to a big extent, that is obviously because they're already using a rigid body controller. So yeah, that is a part of it as well. Now we also have our center of mass on the floor, which probably makes it easy for our rigid body to fall over. So we might need to put some work into actually getting our rigid body in a way that it doesn't fall over. Now, one thing that is, of course, a cheap trick just to prevent that from happening right now, just as a workaround, I am going to remove this once we have things working properly, is we're going to add another collision shape on this. We're going to make that a box. We're going to make that box a bit smaller. And actually, this can be a lot smaller. There we go. And we're going to move that up a bit. So that's now a nice square box on the ground. That should be enough to make sure that our rigid body doesn't easily tip over. Now, obviously, that's not how we want to do it. But because I haven't got the rigid body logic yet, there we go. We are centered. So yeah, now we're no longer falling. Oh no, we still haven't. Okay, I didn't save my thing. I'm still getting weird flickering, which is annoying. And that was back to 1. Is that now changed here? No, gravity scale is back. So our hands should be falling to the floor. Why are they not falling to the floor? No, they're not falling to the floor. It is interesting. So I'm guessing they are actually stuck where they are, because that's the original positioning where we started. So they're not being pulled to our things. And we actually, before we fell over, but because there's a joint, yeah, we fell over onto our hands, basically. That was kind of funny. Okay. So we're obviously, that's just a temporary measure. We're going to have to do that more properly. We're going to have some sort of function that detects whether our rigid body wants to fall over and just, put a force against it to keep it upright. Because we always want our player character to be upright with the gravity vector. So that's something that we're going to be looking at later. Okie doke. So we're here. Very cool. But we're not getting that springy too. So basically he said the same sort of thing here, that his hands, no, we're going too far. So the hands fall to the ground. Okay, so let's put up some joint drives to fix this. Joint drive will drive the rigid body towards a specific position or rotation using the assigned position and rotation targets. So that's a joint drive. So that's all working with spring and dampers. So the big question is, can I get the same logic with a 6DOV by putting on our angular spring? And the big question then is, what are good values for it? Because obviously our limit isn't making it go to where they are. It just, it's kind of remembering the original position, I guess. Okay. Here we do have an angular motor. So that's just making it go to a certain velocity. And that's not what we want. We want it to act as a spring. So we can see whether these values are translatable in any way. And they're doing that on all the different values, okay? All the different axes. And they're doing it on the angular as well. Interestingly enough, the angular spring here is XYZ, but it works in a similar way. So let's just work on that assumption. So 6DOV joints dot linear. Okay, so that's set parameter, I guess. Okay, how does that work on the 6DOV joints? No, it does look like we can access that. So linear spring. Are these properties? Yeah, properties. So I'm not quite sure why it is. So let's start with X. Oh, that needs to maybe be like this then. It's true. Is it happy with that? No, it's not. So do we have a set? We do have a set param. Huh. And the flags. Why does this not work? That's annoying. All right. Well, then we just do it with a set flag and set param. So set flag. Start with that. 6DOV joint dot set flag. Linear spring. True. Okay. Set param X. And that will be linear spring stiffness. We probably want to have that settable somewhere at some point. Damping is 0. And we want to repeat that for the Y and the Z. There we go. Yeah, and eventually we're gonna make this into properties and then make that a bit nicer. Let's just see whether that actually does our spring logic and brings our hands to where our 6DOV are, or whether we're going down the wrong path of this. No, still not doing anything on our thing, which is really annoying me. Okay. Let's first see if it actually has done something. So here are points, so now we can actually see them. That's enabled, that's all fine. Enabled. The motor's off, but our spring is on. Is it something to do with our equilibrium points? Right. Yeah, that's all good. This really makes no sense. That it doesn't do anything. You can see that they're moving, which is really cool. But our rigid bodies are not being attracted to them. So that makes me wonder whether the 6th, oh, you guys couldn't see that because I didn't move it back in here, but it was still doing the wrong thing. So the big question here is, are we setting this up right? Okay, I'm just going to go and create this just to see if that helps us in any way. Because one of the things that I think might be a problem is maybe how this joint works. Because I am assuming that this is now going to attract this to there and also this to there. And whatever can move easiest is going to move there. Maybe that's not the way that it works. So what other joint options do we have? Oh, are you working? Oh, it was just being annoying. Hey, Blake. Huh. So how can we make this work the way that it should? Let's see. Is there anything that this thing does that we do differently? So this is one thing, that it's working with anchors, and we don't have that. So it's adding a configurable joint to the body, connecting the hands to the body, which is basically what we're doing with node A, node B. This is the other thing I don't get. We had that working before, where it indeed had the hands fall to the ground. So one thing that I'm wondering about is it because we don't have any limit here? So we don't give it any freedom to move. Okay. Let's just see if that is a problem with our distances being 0 and whether we can make it move that way. Kind of running out of ideas, but oops. But let's see if that's going to help us in some way. Okay. Linear. Start with the lower limits. Let's give that a bit of a crazy value. I'm guessing this is an upper limit. There we go. And let's repeat that for our Y and Z. Let's see if that gives us any option of our hands actually moving where we expect them to move. No, they're still not doing it. So I'm really wondering, are we doing something with the rigid bodies that we shouldn't be doing? Left hand. Is this thing still... It's not frozen. It's not sleeping. And it's not getting any forces. Okay. Hang on, I just want to make sure. I want to make sure that that bit works. Now they should just fall to the ground because we're not actually doing anything with them. Yeah, boom. So the physics are working on those things. Okay. So we're putting them to the parent body. We're giving them freedom to move. Come on. I wish my headset would just stay on my head instead of trying to fall down. I miss headsets that you can just flip up. Don't make those anymore. Okay, so that is enabled. It has a big upper limit. Okay, let's just say if I make that 10 minus 10, is that going to make any sort of difference? I can just move this around, but nothing happens to my rigid bodies. It makes no sense. It totally makes no sense. I would have expected at least something to happen. You know, I've got these 6 doors. They're linked up to. Yeah, that's good. Rigid body. Yeah, on rigid body on the left hand. The left hand should have top level path on. Let's double check that that's still working. Oh, we do have access lock, so we can use that on the rigid body. That's good. And that's top level. So why is this not reacting to my 6th off joint? And you know, I would have thought that that would be enough. And it should do at least something. But it's doing absolutely nothing. So is the linear spring not implemented on? Well, that could be it. Actually, just for fun, let's go and open this in here. Do I have? I don't have it in here. That's stupid. Okay. Is it XRT2 demo? I can't remember. I just want to rule out that that this is just something that's still missing in Jolt. Where are you? Tutorials. Best. Okay, this should already be compiled, so that should only take a second. In the meantime, I might actually go and look for generic. That went too quick. Come on. Load up. Okay. Let's just see if this wants to run. Okay, that's all good. No, there's nothing different. So not something that was recently fixed then. All right, let's have a look at the source code and see if we can find out. Actually, let's not do that like that. Let's do it like this and go into Jolt. Where are you, Jolt? Jolt physics, joints, 6th off joint. So we got our linear spring frequency. Ah. Oh, limit spring. Isn't that what we enabled? Flag enable linear spring. Flag Oh, that's yeah, okay, that's the other way around. We need to look at this. Oh, it's going through jolt flag. So I'm guessing there's a conversion somewhere. Okay, where do we call set jolt flag from? Okay, where's that called from? We have it defined, but we don't see it anywhere being called from. How does that work then? Oh, that's of course not going to work because we're not actually running it. Well, I'm going to assume that that is actually somehow translated from that. Do we get actually something in our debugger? Doesn't look like it. Let's get something in our output. No. Not quite sure where we get a surface error, but embedded window can't be moved. Yeah, no, that's because now suddenly it's not happy. But welcome. Oh, I want you to be tool. There you go. Let's make you happy. And then let's make that happy too. But none of those are important to what we're experiencing. All right. So, jolt parameter. What have we got here? Well, we got a linear spring frequency. A linear spring max force. Those all make sense. These are really functions that I really would like to access. But I'm guessing that we're setting the damping. But we're never setting a max force. So again, how does it translate from what we are doing to what it wants to do? Okay, so let's go and have a look if we can find some evidence of this. Okay, so those are just the normal ones. Those are all our default values. And it just goes to set flag and set param. So if we go and try and find that as a function, now where is the set param? Here we go. Okay. And param, it gets that one and then is configured. Physics server gets generic 6-dove joint set param for that axis. And it then goes to this one. The physics server, which is now using different names. Oh no, here we go. So we got 6-dove joint. Okay, so what are we doing with that? Okay, now we're getting somewhere. All right, so it's going through set param here. All right, and then change. Okay. What does that do? Spring enabled, frequency damping. Limit spring enabled. Where is it ever setting this? So that's going through there, yeah, but we've never called that. So where are those values coming from? There has to be some sort of translation between calling setParam, which then indeed goes through these. So we got some not supported things. But now here we get spring stiffness and spring damping. Oh, that's interesting. We got angular spring. Is that using the same thing? What? Oh, because it's got yeah, it's probably got 6 values in there. So I can understand that. But how it will ever put this somewhere else makes no sense. Oh, hold on. Here we go. So an update spring parameters. So here we got frequency dampening, okay. Or else it's stiffness and dampening, and then we set our stiffness. But that's the thing, it's a stiffness for that. So all that's going to do is make, if there's a force acting on the hand, it's going to make that, you know, act like a spring as it's moving. But we are moving the joints. We don't have an attracting force. I think that's our problem, is the Sigdorf joint doesn't have an attractor. So is our Sigdorf joint the right joint to use here? Because that is a spring that is calculated from our starting position. And then seeing how much this can move away from its original position and doing a spring function on that. Instead of a, you know, here's an anchor point and I want to, you know, I've got a spring between my anchor point and the object and I want to pull the object to where I am. So this is definitely not working the way that we want it to work. All right, I'm going to take these out again because obviously that's not helping us much. This. Well, one thing that we could try and do is to adjust our target velocity to, but again, that is then also going to be the velocity on the body. I don't think this is going to work. Oh, I did the second one. Okay, how can we make the 6-12 joint do what we want it to do? Actually, this one. Yeah, I actually wanted to create that one. It's locks. Or do I? No, we're going to make that with forces. Unless, no, actually, let's do that, and then we can now remove that guy. So this should allow our rigid body not to, or prevent our rigid body from falling over. Is that going to make it easier to get a logic working? Okay. Well, one thing that I actually want to try just to see if that part of it actually works. So let's at least see if we can go and create a movement control. Based on our movements in both. Okay. Let's put no 3D in there. I'm just going to make something very simple here. Let's actually put that just on here. Movements. There. That's rigid body movement scripts. Yep. Let's go steal this. So left or right hand. Okay. So right hand, and then move action, and that was called movements. Movements. All right. Yeah, why not? So here we can copy a little bit from here. We want our tracker, but in this case, we don't want that, but we want a controller tracker. Should maybe call it controller. Okay, for is get. Oh, that's as a variant. Okay, move action. It's kind of set to vector 2, and it should convert our input properly, I hope. All right. All right. We're just going to make that a strafe movement for now. Oh, the magic number 8. Also, Merry Christmas. There we go. All right, so now we can go apply central force, vector 3. No, we need to adjust that in a minute. So force is going to be vector 3. Is vector 3. Movement dot x 0 movement dot y. And it might need to be that we need to flip that and potentially you know, add a value to scale that and do it times delta, but that's all good. And then force is global basis times force. So we're going to go and redirect that in the direction of what our rigid body is. And again, we might need to flip the x and y around. We will see. And that is the central force that we apply. So let's see if we can actually move around now. Doesn't look like it. But we don't know whether that is because our force is too small. Actually, let's go and do times delta times. Okay. Nope. Let's go print our force and see if this is even working. Okay, our input is not changing our force. Our force is all zeros. So movement, left, movement. We know that we printed, so we know that we're getting something. Okay, let's just do for our inputs is boom, and then we cast it to inputs. I'm going to go and print input here. See if we're actually getting something that makes sense. Come on, figure it out. Yeah. No. Oh, our left one is working and doing something. Probably our force is too little. Oh, because I put it on the left hand, didn't I? Well, let's move that to the right hand because I'm more naturally using the right hand, and let's up the force a bit. Hey, Bush. Hello. Okay. Oh. What are you doing, Bush? All right, come on. What sort of force is going to make this guy move? Maybe it just made him too heavy. Don't. Sorry, my cat's being a bit weird. Oh, yeah, we're having movement. Okay, come on. Say hello to everyone. Say hello, and then go that way. All right, so movement is definitely the wrong way around. I'm going backwards when I should be going forwards. But the most important thing is that the hands are moving along with us. Okay. All right. Okay, so. Now I wonder, because we're using central force, whether it internally already applies delta, because that's really what it feels like. Because that as a value feels way too high. But I'm worried that if I don't apply delta, I don't get, again, you know, I don't know. So let's go back to this. Let's see if that still makes sense. Oh, I should have flipped them around. Definitely feels nice. Okay, so. Oh, I didn't see. Did I need to both flipped around? Oh, let's assume that we need to flip them around both. Let's go and make this something that we can set. Is oops, sports or movement force. I'm actually thinking about changing that to, well, actually, you know what? Let's call that max force. It's actually a nicer one. In the master branch of the editor, you can now open the rightmost menu and uncheck the second checkbox. And the first instance of Godot will run directly in the editor without creating a window with a toolbar at the top. Oh yeah, that's actually kind of cool. We are in a relatively new master. This menu? This menu. I might not be on something new enough just yet. But this is a master build of a couple of days ago. So it does have the new window, but may still be missing some other things. Oops. Of course, the problem in running it in the editor is that we're getting a smaller window. I really had it set up. That's why one of the errors that it gives is I actually had it set up that it would always open up full screen, but then full screen for the stream. So I'm working on a wide monitor, so actually full screen for me is not full screen for you guys. And now that you know, we're not opening it up in full size, which is a bit of a shame. but it is what it is. So yeah, I think that the new way, and especially indeed because I've seen the videos that were posted from when that was still experimental. Running the game inside the editor is really cool when I'm just normally developing, but when I'm streaming, it's annoying. And this new window for streaming is also annoying. So I really want to be easily able to switch between the different approaches. All right, let's also create a turn script for now. Game tab. I don't have a game tab. So I think that I'm probably not on the right version for that just yet. Anyway, actually, I'm just going to copy this over to turn because it's going to be fairly similar. It's still going to be movement. Turn action. This is going to be called max torque. That's probably going to be something much lower. All right, so that's not going to be turn action. Turn, but now the torque, we actually want just the movement X times the max force, or is that a vector? No, that's also a vector, I think. But that is actually we're going to do a rotation around the Y axis. We do want to go and apply that like that, and then apply central, no, apply torque, and that is then called torque. And that needs to become, oh, this is just turn, yeah. Okay. This is going to be max torque. All right. So let's see if that does something nice. Okay, we can, oh, so the left right is still reversed, but forward backwards now works. But turn is not working yet. Which can mean that we're just not giving the right amount. So for turn, let's make the torque a bit higher. Turn is on left, movement is on right. In movement, let's go and flip that one around. And let's see. Yeah, no, the magic number 8, that's really good. I want to test that out because, again, I think for normal development, I think I'm going to really like that and want to be able to use it. It's purely when I'm streaming that I don't think I would want that to be the thing that I'm doing. Anyway, oh, you know why that's not working? Because we're not allowing angular movement. So I just wanted to use the X and Z so that we can't pull over, but rotating is fine for now. Although I think I want to make that work differently anyway, because, whoa, yep. So that wasn't that. Oh, I'm getting dizzy. I'm getting very dizzy. So let's go. Oh, that's the wrong one. Let's go and put that down a bit. And also I noticed that that was the wrong way around. All right, let's see. Okay. Whoa. I bumped into something and it caused me to actually rotate. That was fun. So now when I'm strafing, I'm also rotating. And that is because my hands are probably dragging on my body enough to, unless, hold on. just want to disable that for now. Just rule that out. No. Oh, this sucks. Oh. Huh. Okay, I am not happy about this at all. Okay, so I think we've reached a bit of an impasse here. So what is currently happening? Now this is all running Jolt. So we're on Jolt physics. What's happening right now is because I've paired my hands to my rigid body, and my hands are separate objects. When I move my body, the hands kind of drag down on the body. And that's causing the body to rotate. Cat, what are we doing? What are we doing, Cat? Now you want attention, so you're trying to get me to be upset with you so that I give you attention. The problem with streaming late at night is that's also when my cat gets very active. Come on. Before you dump everything on the ground, come here. Come on, cat. Misty. Hey. Hello. What are you doing? You normally like lying on top of the computer and just relaxing there. Why don't you do that instead? Anyway, so as I am applying a force to move my body, the hands are making the body sort of drag. And because the whole thing that I had hoped for was that because we have our joint, and our joint binds our rigid body to our hand, is that when our rigid body moves, our hand moves according as well. Now, the other option that we have and that we could try is that instead of working with impulse, is we could work with changing the changing the linear and angular velocity directly. But I wonder if that's not going to result in the same thing, because well, I guess we're going to negate our velocity. Excuse me. And it's actually kind of interesting because especially our angular velocity, we're going to hard code what we actually want as the angular velocity. And apply that. Although that also eventually means that we're going to want to call this as a integrated function of our player rig, because our player rig eventually is also going to apply the changes based on our camera movement and our origin movement. Yeah, that's going to be interesting to see how we can deal with that. Because that's one of the problems that we solved with the character body approach. The character body approach allowed us to move the character body exact and to move it in steps. So we could first move it based on the physical movement, and then we can do a second physics step where we move it based on input movement. And now here we're going to go and try and force it to move a certain amount without us actually knowing whether it is going to move there. Yeah, we're going to have to figure that one out. That said, we could plug this into, and then it's not really torque. What we could also do is, well, let's just see if this actually will do what we want it to do. Angular velocity is, I know this is going to be completely the wrong thing. It's also going to be the wrong value, because now we're just hard coding it in rotation per second, which we have now set way too heavy. Well, one thing is we're not getting our rotational movement at the moment. Although we're getting a little bit of imprecise movement, even though that I'm going nicely right. And now I'm getting this. So it's just I'm moving too fast. But it is kind of working. So instead of doing it through torque, max, this is going to be max turn speed. And we probably actually want to go and do this as an angle. So we could actually make that a range. Make it something nice and small. Actually, let's say 0. Let's say 45. Let's say 0.1. And then as hints, we're going to do... God, I always forget what that is. There we go. Radians as degrees. That's what I was looking for. Is it then a separate thing? It might be. Okay, I need to find what that is. Degrees symbol. Let's see if it does that. Second. Let's see, is that indeed? Yeah, degrees per second. Woo. Okay, so on turn. Okay, so that's now max turn speed. I'm going to rename that to turn speed. Actually, let's call that just angular velocity. Now in the right. There we go. All right. So now we've got 45 degrees per second, even though... Oh, we probably... Yeah, but that value is obviously way too big. Let's actually make that a maximum of 90. And let's make that 1 and see what it turns that into. Okay, so... let's say that we can turn at 45 degrees per second. That might still be too much. We'll see. Oh, that's actually pretty damn slow. But at least... And the thing is, now when I move sideways, I'm actually still getting the rotation, but our turn is actually negating that, which is kind of cool. However, this does mean that we need to change the way this works and turn these into actual movement providers so that we can move that logic in the right place. But for now, this will do fine. And I'm even wondering if then the movement we should also be changing to linear velocity and actually hard coding that and creating that as a value, because we want to have pretty much exact control over our movement. Now, the biggest problem that we do have is in our character body, when we take a physical step forward, but the character now moves and hits a wall, we can detect how far we've moved as a result of that, and then only move the XR origin back accordingly, so that if we try to physically move further, we actually do move the camera forward far enough, but our body stays behind and we know how much to adjust it by. While with this, we don't know. So that is a problem that I still have in how to adjust that. Because I don't think, and I could be wrong here, but I can't do that with that. So if I go to rigid body, I don't think there's any move and slide or move and collide or test movement or anything on that. And I also don't think we can do that here. Oh, we can. We actually have a move and collide. All right, that's pretty cool. So we can do it with the move and collide, but then we can't do it with the rotation. Because that's the other thing, is when I turn around physically, I obviously want to move the player body around. But if the player body hits something and it can't fully rotate, we are going to want to know that. We're going to want to know where our player body stops. But again, it is going to be dependent on all the objects that are joined to the rigid body. So then again, because we do have the move and collide, we at least can do the movement. That's at least something. And yeah, and the only problem is that if you turn around and we actually hit something that prevents the turning, we don't have a good way to track that. It would have been so nice if we have a rotate and collide, because that's the other thing. I'm assuming that the move and collide will respect our hands, because that's one of the things that we should be able to test. Now, right now, we should be able to hit this, and we're trying to move the block, but the block's really heavy, so we can move it a little bit, because we have some momentum, but not a lot. So this is important, right? That even though my character body, my rigid body isn't hitting the block yet, because the hands are now hitting that, even though the hands are in the wrong spot, because they're joints, that is doing the right thing. So yeah, now a big question is, because this will work as well, as I cannot turn further than this. But obviously, if I turn my head more, now the nice thing, of course, is my head movement still is linked to my body. But if I physically move forward, I want that to also work. And if I turn around because I'm physically walking around, I can't really demonstrate that because I'm in a chair, I want my player to correctly turn as well. But because I cannot really detect when it is going too far, I have a problem with that. So I'm going to have to figure out a different way to figure out if my movement due to my physical movement is being stopped or not. Because I should only move XR origin back by as much as I've actually moved. Again, with move and collide, I can do that for movement. But I don't think I can. Hey, Obliterato Games, how you going? But I can't do that for rotation just yet. I need to figure that out. And again, I don't even know, because that's actually one of the things that we should test right now, is whether move and collide also respects the fact that we have joints. It's going to be interesting to find out. So we could start with just implementing the move and collide logic and just seeing if that works. Okay, motion needs to be computed with delta. Actually, in this case, not, because I want to move the exact amount. I'm also going to keep my life easy that we're just going to try and keep the origin node underneath the camera node. So yeah, I just want to see, because I want to see if I can get as much working of this, even though I still don't know how to get the hand movement to work the way that it is. But because we have a joint between the hands and the body, we have at least a scenario where we can make sure that if the body moves, the hands move with it. And we need to see if the move and collide respects that. And of course, the other thing is whether the move and collide works independent of the other features that we're using, or if it just adjusts the velocity. Because that is actually something that it doesn't say, even though we're going to go and protect ourselves for that. So here we need to get another physics process. There we go. And here we're just going to handle physical movements. Virtual movement is handled by movement providers. Okay, cool. Sweet. All right. So in this case, we're actually going to be using our origin and camera nodes, because by now they have been updated to the correct position, so we can use that. And like I said, we're just going to make sure that the camera stays above the player. So our required movements, actually that's going to be the difference between where our camera is within the rigid body space. So we're going to actually take our XR camera dot position, and we want the local position, but we're going to also take our XR origin transform, and we're going to put our camera. So we start with get our camera position in local space for our rigid body. All right. All right. So we're working in the rigid body's local space right now. So we don't have to worry about tilt and things like that, because we're going to move in the rigid body's plane. So what we simply are going to remove is, so we're working in the rigid body's local space. Simply remove the horizontal movement. Y is 0. We don't care about that. Boom. So now we know how much the camera is moved from the rigid body in local space. That's how far we want to move the rigid body. All right. Try and move our rigid body to this new location. Okay. Actually, before we do that, we want to I think current position of our rigid Buddy. Remember our current position. And we're going to remember the correct complete transform for that. Is okay, transform 3D is global transform. So we now know where we are in space. Cool. All right. So first get our movement in global space. So that now is going to be required movement is current transform dot basis time required movement. So we get our movement in the current space of the yeah, we're getting our required movement in our global space. This should actually be global. Oh, that's global transform. So we're getting our bases. So that should be good. And then we should be able to say move and collide. Required movement. Do we want to do anything else? No, the rest we can do as is. Okay, figure out how much we really moved. So for that, we're going to get our new global transform, but we're going to put it back into the, yeah, actually not the global position. So we're going to get a new variable called actual movement, and that is going to be current transform dot inverse, maybe a fine inverse, I'm not quite sure. And then we just get the global position. So now we know how much we've moved, but that is the movement in the local space of the rigid body. That's very important. We have this movement in the local space of the rigid body. Very cool. So we can again negate our vertical movements. Y is 0. Counter move our origin points. Because now that we've moved our rigid body forward enough to where our camera is, our origin and our camera have just moved forward by equal amounts. We actually have to move that back by equal amounts. So now we're going to say XR origin dot transform actual movement. So in theory, if I now take a step forward, it should adjust everything correctly. Now, that's going to be a bit tricky to test. So I've just turned this onto not wired anymore, so that I can actually see what I'm doing. All right. And I'm just going to stand up. You guys won't be able to see me for a second. Well, I hope. Oh, I'm of course in stationary mode, so it's not going to be happy with that. Oh, we hit a breakpoint. That's not good. Why did we hit a breakpoint? Transform that origin. That should have been. Okay, let's try it again. Actually, I might be able to at least demonstrate it a bit just by moving the headset around. I'm going to see if that works. Okay, I can actually, as I'm moving this, I can see that our character's moving forward backwards. I think actually that pretty much proves that it does what it needs to be doing. Okay. And again, I want to put that there, and I'm going to see, can I now... I can actually move it, but it is penetrating the things a little bit more. So I'm guessing our move and collide is obviously is not taking the joints into account. It sucks. So yes, we can move and collide our rigid body, but it will ignore the fact that our hands are joined. So I can just move it in there, and then obviously when it's moved far enough, it does push the block away, and that is because this is now penetrating. It basically I can exert infinite force if I want to. Well, what I really want is for the hands to be against this, and when I move more forward, is that obviously the hands get pushed back. Now, obviously, our hands currently aren't working the way that they should, so I might actually end up with that working properly and the hands being against. And if this is a static body, that it actually stops moving my body forward. So that's actually something that we can also test. Is we can get to our test here. We can get our big box. And let's just freeze our box. And turn it into a static body. So now this box should not be able to be pushed around anymore. Let's see what that does to our simulation. So I can move into this and it just stops my movement. It says, nope, we cannot go through a wall. But now when I go forward, okay. So that's interesting because I'm actually getting pushed back because I've got my hands there. All right, so what I now want to do, I want to put myself up against this. And now if I cannot move, because now I can move my head further. My body stays, and I'm not being pushed to the left. I can still move my head. And this is the thing that I do want. This is actually how I want it to work. That's how I really want it to work with the hands as well. So I don't actually want the hands to push me back, because the backwards movement is actually the thing that makes you dizzy. But it's kind of good enough. Now, the other thing that I need to figure out is whether I need to store my velocity. So, var was linear velocity is linear velocity, which now means that I can go and make the linear velocity, zero that out. I'm not sure if this is needed. Come on. But again, I don't want my physical movement to have any impact on how my body is reacting. Okay, and that is then coming back. And again, I don't think move and collide will actually change our linear velocity, because it's actually something that works outside of the move and collide. The move and collide lives a little bit lower in the process. Okay. But, you know, better safe than sorry, I would say. Angular velocity. And again, we're actually overruling our angular velocity later on anyway, so. Although part of what I want to change here is have this logic apply like this, and then probably calculate the angular velocity that we need to face the correct way. And then again, see whether we've actually rotated that much the next frame. And then adjusting, again, adjusting our XR camera equally to our movement. But it's going to be very tricky if there is both movement of our head and movement of, you know, our joystick. But at least that way we can detect how much we need to alter alter our XR origin to make sure that everything lines up. And then one of the things that we can do is actually have our XR camera have its own collision shape, so that when, for instance, because this is a problem that we have right now in XR tools, is when you look or bend over a table, because the rigid body can't move through the table, it gets, the player gets stuck behind the table, and we disallow the head to be above the table. And that's something you can solve with this. But yeah. I still don't know whether this is the right way to do it, because we really don't have well, we have half the logic that we want. That's the problem. And there is a part of me that also sort of says, like, okay, if we move everything into movement providers, which means that none of the movement providers directly influence the rigid body, they give us the amounts of movement that they want to achieve, and we then add the movement that we want to achieve based on physical movement together, so that we know the total movement that we're after. We can then on the next frame see, have we moved enough? Though at that point in time, because we might move the body far enough. Oh, that then needs to be in process. Would that work? That only works if you never run, well, this whole XR stuff only works if you run the physics on the main thread and not on a separate thread. Because else, you know, we have this whole backwards and forwards between letting the physics engine do its thing and actually needing direct results based on our tracking, and then adjusting our tracking accordingly, or we end up doubling up movement. There are other ways of dealing with that. Because one other thing that we could do, I guess, one of the other ways that we could deal with that I'm thinking about if we make the XR origin 3D node a node that has top level path, so that it doesn't automatically move with the rigid body. Then we could see the amount of movement the rigid body did. Yeah, but then the problem is that if you have non-physical movement, your player body would move forward, but your camera wouldn't. So I think when it comes to movement, we cannot avoid doing things directly in the frame like this. So confirming that we move the right amount forward so that we can move the XR origin the same amount back. And the same with rotation. If the camera rotates and we want the player body to follow, we have to immediately know how far that rotation has worked. But that means that we're not applying the joints correctly. Because again, that's the problem with the physics engine. The physics engine isn't designed to work direct. So like this move and collide that immediately updates the position, that's not how the physics engine normally works. You know, the normal behavior is you're setting all the velocities that you want, and then you have the physics logic running on the physics server, and then you get your end result. And we can't use that for XR. If XR, we need it to be more direct. At least for the physical movement, at least for the, you know, I'm taking a step forward or I'm physically turning my body. Because else you get out of sync. Because, you know, you have these two contradicting systems. And they need to line up. How to deal with that? I don't know. And that way character bodies are so much easier, but character bodies don't apply the forces correctly. The other option, I guess, would be to use two helper nodes. Move those to where we want the body to move to create a target location, but stagger, you know, the lower movement being the virtual movement and the upper movement being our physical movement, then trying to move our rigid body to that location using our angular and linear velocity to try and get there so that it does the right logic. And then we can compare how much the movement actually is. And if we reach it, we can fully negate the... But then again, the problem that I have is we won't know until the physics simulation has run. So when do we adjust it? At what point in time can we do that? And if we are not too late? And you know, I guess we could do that, you know, that adjustment in process itself. Because again, if we don't run physics in a separate thread, we know that by the time process runs, physics has done its work. Especially if you do physics in lockstep with process. So at that point in time, we can make sure that the camera moves correctly. Can we make it work that way? Sorry, guys. I'm just thinking about how I could make this work the way that makes sense. Where both the physical movement and virtual movement are combined, but that if we don't reach our destination, then I can figure out whether we could have gotten there or how far we could have gotten with our physical movement. Or that if we don't get there, we do some sort of factorial change that we say, okay, if we stepped half a meter forward, but our velocity means that we move 2 meters. So in total, we should have moved 2.5 meters forward, but we're only moving a meter forward. Does that mean that we've done a complete physical step and then the rest we haven't? Especially, of course, if we're slowing down, right? So we would have made half a meter forward as a step physically, but then we slow down because we put our our joystick like back. Back like that. How do we contribute how much we've moved? That's a difficult bit. Because again, if we assume that we haven't fully made the movement for the origin, just doing my head in. I really wish that we could separate out the physical movement and the virtual movement. And we could tell the physics engine, here's our physical movement, process that first, do all the collisions according to that, forget for a moment that you had virtual movement, and then do a second run of the physics simulation, but now for our virtual movement. That's really what we need to do. Now, one way that we can fake that that would be really mean, is we could put our physics rate to twice our FPS. And we could just have a switch in our physics process here where on one physics iteration we do this, we store the linear velocity and angular velocity and set those to 0. But then instead of doing this sort of movement, we actually set our linear velocity and angular velocity to what we want. And then on the second frame, we restore the linear and angular velocity, do our virtual movement, and ignore our physical movement. And in theory, that should work because we do one frame, we do our physical movement, and one frame we do our virtual movement. But if we don't run exactly double frame, the physics rate on double the frame rate, and I bet you there's going to be a whole bunch of other issues with that, because if something heads towards the player and hits the player, and it hits it in the frame that we're just doing the physical movement, we might not get a proper transfer of power. Dang. Oh, this is doing my head in. Let's see. Is there anything in the physics engine? Sure, 3D. There we go. Is there anything in here that we can say, like, force doing your calculation for a body? I think I might have to ask that on the physics forum and see if someone can answer that. No, there's definitely not something that we can say like a processor frame for this object. All right, I do believe that this is about as far as I can take this experiment for tonight. I'm going to have to start asking some questions on the physics forum and see if anybody has some advice here. But I think I have stretched the limit of what we can do with this approach. Without actually, finding answers to some of the problems that I'm trying to solve. So yeah, I think I'm going to leave it there, guys. I hope this was still interesting. I'm sorry that we didn't get where I hoped that we would get. It's still been a good amount of experimentation and figuring out how certain things work and getting puzzled about how some other things don't work. I'm going to think this through a little bit longer and try and figure out if there's some other idea that I can gather on how I can make this work properly. But for now, I think this is as far as I can take it. So I'm going to leave it here. I'm probably going to try and do another stream either this weekend or early next week. And at that point, I want to start having a look at doing some more with the spectator camera with this little guy, because I want to make sure that we get some interaction stuff going, that we can actually move the camera around. Maybe I figure out an alternative to my original problem, because the thing that I'm trying to solve here isn't necessarily that our player should be a rigid body. I would be very happy if we can keep it, a character body with the current functionality, but I need a way that as the character body moves around, my hands move with it. Now, there might be some ways to fake that. I might still be able to do this. One of the nice things about do I still have it? No, I don't. So if we look at our generic 6DOF, the help says that if I leave one of these two alone, then one of them is going to act like a static body, which means that the, if the static body node moves, or I'm guessing if the 6DOF node moves, it will push the hand forward, hopefully. But other than that, the hand is still going to have a life of its own. So that might be a solve for my body movement problem. That's actually that might be a nice one just to try and see if we can make that work. Let's do that before we call the end of the stream, and see if we can actually get that bit to do something semi-sensible. So let's go close you. Let's go close you. Let's close you. Let's go back to our normal stage. This guy that we prepared before. Hello. Okay. So what we're now going to do. Oh yeah, we need to now make sure that that becomes the stage that we actually open. So we're going to go over here. We're going to go over here. Save. And on our main stage, we're now going to go to our hands. So I actually made a player script there. And then we got our left collision hand and our right collision hand. So let's go to our collision hand script. What was... Okay, so let's go, and we're just going to drop it in and see if it works. Might not. It might so. So let's just go and put it over here. Let's go 6 of joints is generic. What is it, boss? Hey, suddenly asking for attention again. All right, so pose. Where's our ready function? Come on, there's too many things in here. Ready. Okay, so we're not going to do it anywhere here. We're going to do it here. So we are actually getting our parent. Here we have our parent. We got our exception there. Do we already know whether we have... No, that is a collision hand. So add a joint to our parent for this hand. So now we're gonna say is... Oh, is this again in... That's in ready, so we can't do that in ready. We have to move that into physics. Okay. Okay, so we're not remembering our parents. Not quite sure I'm happy with that. We might need to change that. Okay. Freeze true, freeze true. Actually, let's do that all the way at the end here. Boom. So what I'm going to do here is if not 6 of joint and parents. Yep, I know, because we're going to create that. Oh, actually, you know what? We're just going to say, if we don't have 6 off joints, then we're going to grab our parent because we only need this once. That's actually always created so that we so that if we turn out to not be able to use this, we will no, we should do it like that. And then it's going to no. We are going to store this. Because again, I'm a little bit afraid that we're going to do it every frame and it's going to be slowing us down, and that just doesn't make any sense. So, var parent, actually let's call that parent body, collision, object 3D, there we go, very cool. And now in our ready function, we're going to say parent body is get collision parent. If we find it, we're going to make an exception with our collision so we don't hit our hand against our own parent, which is cool. And then now here, we're going to say that, which means we can now do an add child 6th of joint falls turtle back. So there we go. We're going to add that in. Then we need to do our 6th of joint dots node A is self dots. Actually, just get path. Ha! Hey, no, not a dev. Returning from the void. Well, you're lucky to still find me here because I was about to end the stream, but I got one more idea that I wanted to try. So, in this case, we're just using this to move our hands with our body, but we're anchoring it by adding our 6th of joint to our parent body, and that should therefore anchor it on the parent body itself. And hopefully that's enough to not inhibit our movement of our actual hands. But it does mean, hopefully, that when our parent body moves, it moves our hands with us. So let's see if that works, or if we completely made this impossible to work. Oh, oops, that's of course going to not work because Steam Link stopped working again. Yay! So I'm actually surprised that this is currently stuck. Let's just see if this actually gets somewhere. Because Godot should now have said, no, I'm not going to work. Dismiss. Boom, let's get that out of the way. Maybe. Yeah, session mismatch. It always does that. Let's try this again. All right. I have a feeling that Steam Link fixed something. That instead of just exiting. All right. Whoa. Something suddenly. It doesn't like what I've done. Is it? It's still running. All right. It was not happy. Is that because of what we've done, or is that because of something else? Okay, and I think it is about time that I restart a few things. Okay. Let's try and just do this first. Okay, Steam VR is running again. And let's see if Godot is happy again. Okay, so we're kind of... What the heck? Yeah, so our joint and our forces on our hand are now absolutely unhappy about how they work together. So now I'm starting to wonder, because it is still kind of moving around. The angular is not working. Okay. but we're kind of doing what we wanted to do. So what if I just go? So what if I go and place these guys? So we're gonna make a little bit of a mash up between what we were working on before and what I'm working on now. So in this case, here we have a target. So what if we just say, if we successfully created it, we're just going to say 6.joint.global transform is target. Let's see what sort of difference that makes. So now it's still childed to our character body, which will mean that it was going to be moving with that. It doesn't make it much better. Yeah, I don't know. Yeah, because I added it to the parent body. That's fine. Well, probably for testing, we just want to go and create something to visualize it again. So let's create a mesh as a. Let's do a box mesh this time. Okay, mesh.size is vector 3, 0.1, 0.1, 0.1. Var mesh instance 3D is mesh instance 3D.new mesh instance mesh is mesh, and then 6.joint add child mesh instance. Okay, so the 6.off is definitely in the place where we expect it to be. But our hand movement has nothing to do. You know, obviously it's taking the forces into account, but it's not allowing us to move it to where it's supposed to go. So yeah, and even this doesn't even do anything remotely what I expect, because what I'm expecting with them joined to the physics body is that as I move my body around, I would be expecting the hands to move accordingly because they're joined, but no cigar there. Well, it was worth a try, but no cigar. So let's take that out because that's obviously not working. I'm happy to keep the parent body in there. That might actually be useful at some point. But this bit is not working. Let's see if everything goes back to normal. So yeah, this is the problem that I'm trying to solve. The fact that when I move, my hands lag behind because I cannot accurately give it the right force to do what it should be doing. So, and for some reason my hands vibrate a little bit now because I cannot accurately determine the the amount of force that it needs to apply to move the hands. So no solution yet, but still, you know, failure, we learn things, so it's not a waste of time. We still learned a lot of things about how certain things work, and also about how certain things do not work. And I've got some interesting questions to ask the people on the forums and see if anybody can give me some info about that. All right. That's where I am going to leave it for real tonight. So thank you all for watching. I hope it was still very interesting, even though we didn't get where it was that we wanted to get to. But, you know, we learned a bit and we did some fun things. And like I said before, I am planning to stream either this weekend or early next week. And we're going to go and have a look if we can create some interactive logic to move our spectator cam around and make sure that that can get positioned nicely. So that is where I'm going to leave you guys. Thank you all for joining, and see you all on the next stream.